Hi and welcome. This is a pre-recorded session. Right now I may welcome you from the hotel in South Africa, Cape Town, where I'm currently spending the week working with the archives here. So I'm honored to bring you this live from the southern part of the world. What I'm going to show you today is the amazing color changing card trick. Actually no, but it may seem like one. So where do we start? I like to start with a small joke. Imagine this. A bitmap, a PNG and a TIFF meet on a classical file system, like here on my disk. And the bitmap is really sad and it goes like, oh no, I can never have a title. I was never, like, my file format was just never designed to have a title. I just can't have a title. It's only gonna be the file name for me. The PNG says, I understand you there. You know what? In my standard, I actually can have a title and other annotation metadata. But no one really bothers to notice or take care about this. And so hardly any applications support it. While next to them, the TIFF is standing and it goes like, I don't even hear you guys. I'm library standard. I can have so much metadata you couldn't even imagine. Then sometime later, all three of them meet again on AHAlodeck. And the bitmap is very happy. And it says, I have a title, I finally have a title. And the PNG is also very happy. And it goes like, yeah, because now we both have a title and all kinds of other metadata, so that everyone can see and uses it in the same way as anyone else. Well, the TIFF is not so happy about this. And suddenly, another file comes up, a text file that says, hi, what are you doing here? And they're like, yeah, we're celebrating that we finally have metadata. And I'm like, oh, cool. Me too? And I'm like, yeah, because now the metadata moved to the file system where your file name actually is stored, so we can all have key value annotations independent of what kind of file we are. So the text file said, cool, so I can like, so text file is a text file and it has text in there. Where would you put the title? So maybe the joke was not too helpful, maybe it was more confusing, but look at this. I really have three files here, three image files, a TIFF, a bitmap and a PNG. And actually I did set a title for a PNG, and the TIFF and the bitmap, as the file format specifications really never intended it for having any annotation information. It can't have a title inside its file. So we're speaking about, or I'm speaking about, embedded metadata. Stuff that you may know from MP3s or other file formats, where you can actually put annotation metadata inside a file. So that if you copy it or you change the file name, it stays. But where is this embedded metadata? It's embedded inside a file. So with the TIFF, what would I do? I would go like properties. Image. Depending on what I use here, it may or may not show me all kinds of metadata inside some file format. So without the TIFF here, I don't really see a lot. I see resolution in pixels. I know it has a title because I set it, but I don't see it here. PNG, right click, properties, image, same here. I will do the same for the bitmap. So that's not really helping. This is a file manager, so I'm on a Xubuntu Linux here. This is X-Phase4, and this is just one of many file managers out there. When it comes to editing and accessing embedded metadata, you need special tools, or sometimes, well, we'll see more on that later. But now, you see, it's already a bit tricky getting access to this metadata. I can open this with an image program, image, metadata, view metadata, and I hope you can read this, maybe a bit small. So there's a lot of technical metadata, as you can see. I've opened the TIFF now, and here you've got XMP, and ta-da, there it is, XMP, doubling chord title, here is, this is a rose, TIFF. So yeah, I kept my promise. I've annotated a file inside using embedded metadata. I'll kind of fast forward. So one thing is that the PNG, let's show it on the shell. There's a tool called xiftool that can parse all kinds of file formats and just extract whatever metadata it finds, technical as well as descriptive metadata. Sorry, xiftool. It's quite late here already because I'm going to re-record this just in case something happens, because I don't know what I'll find when I'm on campus of the university, and so I'd rather be safe than sorry and have this recorded so you actually have the content of the workshop. xiftool. Here's the TIFF. All kinds of information. It's, here we go. This is a title. This is a rose. xiftool, PNG, auto metadata, title, this is a rose. Bitmap doesn't have that field. Tough luck. What's my point? Imagine you could save metadata in the file system with a file, with a data object, independent of its file format. That's how I'll start the amazing color changing card trick. So, as I told you in the disclaimer, this is like ongoing research and development. So what I'm showing you here is new in one way, that there's not really a lot of tools known or existing, especially in the graphical user interface, that support these features. But actually, the ability to store this annotation metadata in the file system, it's 20 years old. It's from the late 90s, early 2000s. More on that. Check this out. I'm going to say set. So on a Linux system, I'd first do like apt install extended attributes. If I install this package, I'll say I already have it installed. Now I have the commands for set the file system attributes. I would like to set a key called DC, short for doubling core, title. I can just choose these key names as I like, and set a value. Yes, this is a rose. And I would like to actually apply this to all my images. Now what happened if I say get file system attributes, dump all of them, match any for, here's the TIFF, DC title, yes, this is a rose. This is exactly what I just said. But I can also have this on all three of these images. So that's why the bitmap and the PNG are really happy, because they can all, you see, they all become equal now. I can just annotate files. Where is this information stored? In the file system. What is the file system? The file system basically is the thing that keeps your bits and bytes that are on whatever storage, like on your hard disk, on your flash drive, on your anywhere basically, that keeps the folder structure and the file name and like which bits and bytes belong together and form that structure. And this is where the file name is stored, where the access rights are stored, stuff like this. So for you who are more familiar with the graphical environment, stuff like the size and the date, the modification dates, things like if I click properties here, I get like modification dates and the file name, and that's the file system. And on POSIX compliant file system, so this applies to a lot of file systems in the Linux world and also macOS. So macOS uses these extended attributes, the extended file attributes. Linux uses them. They're just not popular, and they're actually a POSIX standard since I think it was around 2003. So why I'm doing a lot of command line here is because there just is not really a graphical user interface to deal with these attributes. But working with collections and files, I hope you can appreciate what this opens up for possibilities. Let's play around a bit more. So I said, well, the text file can also contain attributes now. I can do the same thing. I just say set attribute and do the same thing to the text file. Up there I had this get file system attribute. I set myself an alias for get extended attributes, so I don't have to type this all the time. I just can say gx file and it will give me the attributes. I can also add more than one attribute by just adding more. Creator ta-da! I set the second field. The key names, so that's the key, that's the value. For certain reasons right now the key names have to start with user. Long story, you can read up on that. But everything afterwards right now is up to you or me or whoever to set it. It makes sense to stay to certain structures. I will not repeat basic cataloging and metadata handling here. It's just that you can set key value, key value, key value, key value. What I wrote, because that was missing, was a quick proof of concept graphical user interface to do this. I can right click, edit metadata, because that's what I always wanted to do. Like, imagine you have the ability on wherever you are, whatever file type it is, right click, edit metadata, and you just have your key value stuff there. So here, this is the field that I just set. So I'm accessing the same information just with a different tool. Speaking about different tools, what are we annotating things for? So we want to search and find them and restructure them and so on and so forth. Here's recall. It's a tool that knows nothing about what I'm actually doing here. But recall is an indexing tool that can go through parts of the file system, like index files and folders, reads all kind of embedded metadata and full text search and whatnot. I set it, I pointed it to this demonstration folder that I have here. I'm going to update the index. I'm going to say rows. And here it found me the TIFF and the PNG title, and it also showed my bitmap and my plain.txt because it found it in text. That's my text file, sorry. Here's there, extended attributes. Yes, this is a rows. So I configured recall to also index any extended attribute it finds. Do you realize what this means? That I can... So what I've just shown you now in this few minutes is you can take any file, regardless what file format, even a text file. So here it says, you see, DC Creator, P2B, and yes, this is a rows, which it isn't. But you get the idea that you can annotate anything now. It gets better. So now all these 3 files and my text file can be annotated on the file system level. Now check this out. I'm gonna create an empty file. This is let's say I just call it test.db. You see why. I can say edit metadata, add a new entry, and I'm gonna go user dot something and add a new entry, user dot I'm just like, imagine this is a database entry. This is something where you would like to just annotate something else, like let's say a relationship. User dot I have a better one for this. We'll get back to this. Here is another folder with another set of examples. So I've got a JPEG image here, which is the cover from a music album, and I've got a music file, an MP3. So I was talking about embedded metadata. We'll get to cataloging and databases a bit later. Let's not hurry. So there's my MP3 file. And of course, MP3 files are very popular for their embedded metadata. And here you see that even the file manager says, hey cool, this is an MP3. I'll give you the fields, at least the most common fields for this, and it even allows me to edit them. This information is stored inside the file. And depending on the file format, there's different tools, different anything. It's like if it's an MP3 or an MP4, even the title information or artist or album, which is common information for music collections, need to be defined in the file format somehow, in the file format standard, and supported by each and every application again and again for each and every file format. So yeah, and that's just for accessing, reading it, and writing is the whole thing, but just harder. So there I have my MP3 file, and I can of course open a music player now, like some media player. I'll take VLC. Up. VLC understands that the cover image, that there's a cover.jpg and loads that. Here there's a tab called metadata, but actually it's not showing the descriptive metadata, and VLC puts this on the general. So you see the fields here, embedded metadata fields, title, title, artist, album. They're like the basic fields for music collections. Then comment, comments, genre, and so on. So you see there's more fields here, and this, it calls it date, and this one says year. But yeah, different applications title these fields differently. Anyways, that's accessing MP3 metadata, because MP3 is a very good example of embedded metadata that is so popular that it just works, it feels seamless. Still, it's inside the file. What if I want to edit that metadata? I'm not sure if you're familiar with hash codes, checksums. I'm going to do an MD5 of that file because I'm going to change that file. This is a hash code. A hash code is like a digital fingerprint that I can use to check the integrity of a file. So if any single bit of this MP3 file should change, the MD5 sum will be completely different. I'll make a copy just to be sure, and I will now just add this. Doesn't make sense. I'm just wanted to show you that we can make it a dot. Save. What happened was that, well, they still have pretty much the same size. They in fact do have the same size, but if I compare their checksums, you've got this checksum and this. So the file was changed. It's not the same file anymore. I hope you still enjoy this little command line show. Visual binary diff is a tool that I often use to show me the differences between files. So I say, okay, show me what's changed. So this is an hex editor view. I hope I'm not scaring you off. It's basically, this is looking at binary data. I just want to see I've changed a single dot of annotation metadata, and it completely changed a lot of everything that's read is difference between these two files. So you see the metadata in there, and everything that read is changed now because it inserted a character and shifted out a character. So basically I've changed a whole file. I've changed my whole audio file just because I wanted to change annotation information. That's embedded metadata. It's inside. And so the whole file changed, and so the hash code changed. And for every one of you who knows how dealing with data and integrity is, yeah, that's something. This is embedded metadata, and that's how it is. The rest of the file, so here's the musical contents, they are identical, they weren't changed. What if I would do the same as with the image files? Use extended file attributes to store this metadata not inside the file but with the file in the file system. So there's EXIF tool again. Everything I'm showing you here are like proof of concept pieces and puzzles that are there to give you an idea of the possibilities if we were able to harness the power of the file system as a database or for annotation purposes. Check this out. EXIF tool, here's my MP3 file, and I get a lot of information. Technical metadata, file system metadata, and the embedded metadata from inside the file copied outside. So there, artist, composer, and so on. Excuse me, I'll fetch some water. So EXIF tool can read a lot of files, like media files, image files, a lot of different media files. And I wrote a very simple shell script that takes the EXIF information and actually just, as you see it here, copy pastes it from inside or wherever it finds from inside the file or wherever it finds the metadata, takes it and copies it as an attribute in the file system. So lots of noise there. And if I now right click, edit metadata, I get the metadata. So all the keys that you saw that EXIF tool can extract, I now have on the file system level. I'm not going inside the file. I'm not going inside the MP3. I'm on the file system level, where your file name is. I'm outside of the file, but I'm with the file object. So I could copy this file around and this information would stay with the file. Here's edit metadata on the MP3 before I did this. Oh yeah, that's something else I did before in my test. I actually wrote the hash code on the file object, which is, for every one of you who deals with data integrity, you will understand that this is great, because now you don't need to have a sidecar file. But so you see, that's like, it's both an MP3 file, but one now has the metadata accessible and the other one still hasn't. I'll let go of this copy now, because I find it kind of confusing to have it around still. What I'm doing now is I will create what I call a thin copy. So I take the MP3 file and I copy only the extended attributes, only the metadata. I leave behind what you actually call the file contents, the payload. What I now have is a 0-byte file that, if I open it with a text editor or whatever, it just says this file is empty. But if I right-click edit metadata on this file, here's your metadata. And this is exactly the metadata from that MP3 file. What you see here is basically the MP3 file with the metadata, and just the metadata, which you can think of as like a database entry. It's just metadata now that refers to some song file that is lying next to there as MP3. That's why I call it song.db, for like, this is technically like a database entry. Because what is a database? A database is classical, conventional, relational databases are so-called tables. Tables with fields. Fields have names. Basically what you have is a set of key values. And what I've shown you here now is a set of key values. This means you can use the file system just like a database. I've prepared some examples. One thing is, here, all of those 0 bytes, I'm just using the file system as a database by adding annotation information, key value, key value, key value, key value, to file system objects. Here's a film database entry. Maybe it seems familiar. Sorry, this is my proof of concept application. It's written really badly just to show off, so it's not resizing, so it's kind of like a small window into the world, but I hope you get the idea. So there's your keys, there's your values, and this is, Heidi will probably recognize this. It's an example of a real film. Now you have all these fields here, AN, FI, AH, ER, CA, and so on and so forth. Key value. I just use this to show you that the key names don't really matter. They have to be prefixed with user for file system standard reasons. But this user prefix can be shown or not shown depending on the application. So what is everything you see here is just a showcase of a proof of concept. Don't get hooked on some details of, but this looks like this, or the application doesn't scale. Please use your imagination and your professional experience to understand what I'm showing you here. Because what I'm now showing you is something that, well, you see, this is a database entry. It's the equivalent of a database entry, but it's here on the file system level. I copy this over just to show off. I'm going to make a new folder, test, I'm going to copy it in this folder, right click, edit, metadata. There you are. So you can actually copy metadata entries, like database entries around like files, because they are files. I rather like to call them objects at this point, because this is a gateway into a new way of dealing with data generally. Because it's dissolving the barriers between meta and data. It's moving some things that were until now, or are until now, a matter of the file format. They're moving it to the file system. I don't know if you remember, but until 1995 and Windows 95, file names and file systems used to be very limited. They only were allowed to have 8 characters, uppercase only, ASCII only letters, then a dot, and then 3 characters. So that's why there's JPEG and JPEG and HTML and HTML, like JPG, JPEG, because for a very long time, until 1995, for most of the world, file names could only have 8 characters, a dot, and then 3 for the extension. So having 4 letters or longer, or long file names in general, it's quite young. I like to compare this, what I discovered here, that this feature of extended file attributes, I said they're like 20 years old. Why? Why is this not officially used? Well, actually it is used. It just never became popular enough to breach the perception barrier. For example, if the long file names as a feature of the file system, I mean, you know, long file names with all the pros and cons, and we even now have long file names with Unicode characters. You can put emojis in file names. Download something off the internet and you'll have the emoji in your file name, or any other special character. This is just my way of saying that if there's a will, there's a way. Now, why are these extended attributes not more popular? Because I think embedded just worked too well for too long, so that people were like, nah, we already have embedded metadata, it's okay. But with now, when you deal with mixed collections and other things like that, the variety of file formats and the code you need, and it's just, there's more issues. How to say? It's 11:15 at night now, so I'm actually a bit tired now. Imagine long file names would have been a feature of, let's say, some sort of Linux. Same year, same thing. Would you like to live without long file names? Could you live with 8 characters, ASCII uppercase only? Do you consider this relevant when you create files, even for professional large-scale collections? Like, hey, only 8 characters, uppercase ASCII only. There are some characters that you want to keep out of file names, because a file name still is a technical handle. But we're beyond 8 characters. The world is beyond ASCII only. We're in long file names. And if that feature would have been presented in not the mainstream operating system the world just used, which was Windows 95 back then, you may not use long file names by now. So these extended attributes were introduced. macOS has it, Linux has it, Microsoft has some sort of it too, but macOS actually uses it, Linux uses it. I don't know if Windows uses it. And so anything you can read on extended attributes, or resource forks as it's called in macOS, and named resource on NTFS. Anyways, it's the time probably wasn't right for that, and it's still a resource thing. Meaning that at the late 90s, early 2000s, when this was proposed, maybe the time wasn't ready yet. But now, I already showed you that I can search this, and I said, here, this is a rose. RAM and memory are not a real concern when it comes to things like metadata, but they actually were of concern in the early 2000s. Like the things were storage was more expensive, you didn't have that much space and not memory, so indexing and searching and handling all this maybe was just a bit too much. Now I'll update my index again, and well, yeah, so there was this thing, right? I said I'm going to use the file system as a database. So we have this Frank here. I'm going to do Frank, or I get suggestions because my index already picked it up. Here's my film database file. By the way, both of them, the one that I have examples and examples test. And if I do preview on this, here you go. Welcome to the future, or like the past. These are the extended file system attributes that I put with a zero database file. So literally I can use the file system as a database. And by showing you this, actually I prove my point. And it looks kind of nice already. This is all looks and user interfaces and the handling of this can be improved. And what's absolutely missing in everything I'm showing you here is querying by relationships. Relationships what? I mean, in databases, there's related objects. So how to make this? Let's say back to media. I will create a empty file, relation.db. It doesn't matter what you call it. I just call it db to remind you that it's like behaving like a database entry. And I can do this. I can say add, then user dot cover art is cover.jpg, and add new entry user dot album dot title is that thing's done. Feels like adding a database, right? User dot song is, and I'm not going to type that. I'm just going to take this. Voila. Save. And there you go. I just I'll show it here. Here. So I'm accessing the same information with basic tools that exist. So accessing extended attributes is very easy. It's like super easy. As I said, you can like install default packages. For any programming language, you get a library that is able to read and write extended attributes. And I just did this. I said, so this, I just put like an annotation here, like album title string. Cover art, here's an image file, here's an audio file. And I just made a relationship. I just can describe information. I'm really literally using the file system as a database. What else do we have? I'll go back to my examples. I'm going to delete the copy. So this is my example with all these fields with only 2 letters. for historical reasons. What I can now do is something. Imagine you'd have yet another metadata file. All of them have 0 bytes, and I use it as a mapping. So I say AN is work identifier. So this is like an object identifier, accession number, AN. FI, identifying title, AR, FIAF archives. And so I can use this like a lookup table, like this key goes in and should be mapped to that key value. So I can basically make mappings where I can translate one key to another. And I can exchange my mapping information. You know how? You know how I can actually now share all my metadata with you? I've shown you the thin copies, where I took an MP3 file, de-embedded the metadata onto the file system, like whatever file format you get any tool to read the metadata, you can basically do that. I created this metadata file with a copy of just the metadata, and I could do this for any media I have with the whole file system structure, like folders. I could take a whole music collection or film collection or any collection, de-embed the metadata, put it as extended attributes, then create thin copies and copy this to you. This is a handful of kilobytes, maybe a few megabytes. And if you're unhappy, or if there's it doesn't have any content. So I just said, like, show me all the metadata of all the files that are in the folder. So it says here, film database, you get a nice overview of this is that. Treasure map is these key names mapped to these key names. And so what I can do is just, I can create an archive. I just tar this, and tar actually supports extended attributes. Extended file system attributes. Here, extended attributes, if you tar this, so I'll do it manually before the battery of my notebook runs out. Tar xattrs, what was it again? Mentar extended xattrs. Xattrs, then collection tar where am I? Tar CVF examples. Okay. Here's my collection. Inside is 0-something files, and if I open this tar file now in a hex editor, just to show you, like, see the metadata, it's in there. There you go. So all the extended attributes are there. I just packed a bunch of 0-byte files like a database, and now I can copy you this, so it's 10 kilobytes. And imagine you can do this on any file format, on anything, and all of this works out of the box on most Linux and Mac machines. What I also did was, out of curiosity, I took files with extended attributes and copied them over the network, over Samba network share, onto a ZFS network server and back. And if you configure them properly, it's a few flags to set, basically one flag in Samba. You can copy extended attributes back and forth. So this is a showcase for using extended attributes to be able to use the file system, the stuff that where your file name is, to annotate any digital object. Where I'd like to go now is to mature this. So what's actually missing are the graphical user interfaces and also things that make it like more comfortable to work with this. But so far for now, and I'm really looking forward to discussion, questions and answers, and I hope you enjoyed the show. This was the amazing color changing card tricks with no, actually this was my AHAlodeck by August AHAlodeck demonstration. Thank you. See ya.